Chapter 1, Section 4, The Motion of the Moon. Probably have to break this lecture up into two parts. We have a lot to talk about. Let's start with the phases of the moon. Hopefully at some point in life you learn the phases, so this will be a little recap of the different phases. But why are there phases? Well, the first thing, of course, the moon orbits the Earth. I don't know if you've ever thought about this, but how far does the moon go, let's say, in an hour or a day or whatever? Well, it turns out the moon moves about its own width each hour. Now, how wide is the moon in the sky? Well, it turns out if you hold up your thumb at arm's length, okay, and line it up, the width of your thumb is about the same as the width of the moon, which is half a degree. Half a degree. So the moon, on its own, moves about half a degree in the sky every single hour. Now, if you go into a movie and come out 2 hours later, it will have moved a lot more than that 1 degree. Why? Because the Earth is turning. Now, the Earth's turning at 15 degrees per hour. So while you're in the movie theater, the Earth has spun 30 degrees, and the moon will have moved up in the sky a lot more due to that than due to its own motion. But anyway, slowly but surely, the moon does orbit the Earth, and that's why we see the phases. Now, the phases, we go through a cycle of phases in about 30 days, 29 and a half days. That should seem kind of obvious. Of course, that's about the same as the length of a month. That's where we get months from, or in the Old English, moons. Yeah, a lot of people don't realize that. There are 12 moons in a year. So, of course, that was based on ancient people didn't really know the physics of the moon. They just looked at the phases and know, when we've been from one full moon to the next. That's what they based it on. As the moon is, as we're becoming more illuminated during the month, we say that it's waxing. And after it reaches a full moon, then it is waning as we see less of it. That little bit of a wobble, if you watch this, is kind of cool. It's called lunation. And that's due to the fact that the moon's orbit isn't a perfect circle. It's an ellipse. And so during the month, there's a slight shift there. It makes it kind of wobble. Kind of cool. As it goes through the phases there, if you're wondering. All right, well, let's start very quickly here with a new moon. A new moon is when the moon is located between the sun and the Earth. So you spin around at night. Again, remember, the moon is between the sun and the Earth. When you spin around at night, you're spinning away from the sun, which means you're spinning away from the moon. New moon really means no moon. There's no moon out at night. You can stay out all night long. You're not going to see the moon because it's out in the daytime. So that's a new moon. New moon, no moon. So for, 2-3 days a month, you're just not going to see it at all. And then it starts, you get this little sliver of a moon, crescent moon in the western sky right after sunset. Happened to see one just a few minutes ago from our school garden. And that's called a waxing crescent. And so about 1 week after the new moon, you get half of the face of the moon is illuminated, which is the first quarter moon. Then when the majority of the moon is lit up, it's called a gibbous moon. So that'd be a waxing gibbous, and then you get to a full moon. Now, how long do you think it takes to get from a new moon to a full moon? About 2 weeks. That's about half of the month. And guess what? The other half of the month is going to be when the moon is waning from a full moon back to a new moon. All right, so that's where we get the months from. And as you saw there, the average is about 30 days. This is a really great applet we do in class. I'm not going to get into it right here. That shows how exactly the shadows from the position of the sun and the Earth and the moon could create the phases. Of course, another thing that is affected by the moon and by the sun, which a lot of people forget, are the tides. Yeah, the tides. So if you look at the top of the picture here, a neap tide, you have the sun, earth, and moon are at kind of right angles. And what's happening is the sun's gravity is pulling the water of the earth in one direction. The moon is really working against it. And so they somewhat cancel each other out. And so the tides are not as extreme when it's a neap tide like that, because the sun's gravity and the moon's gravity working against each other. The moon has more of an effect because it's much closer, much closer than the sun. So its effect on our tides is greater. but the sun plays an impact. So when it's a spring tide is when the sun, earth, and moon are all in the same plane, like in the bottom two pictures, and their gravity's working together to pull the water out in the same direction. As Earth spins around, we get particularly large tides called spring tides. Spring tides, kind of cool. Here's a question for you. Taking a look here. Let's tie this in now with the phases. What do you think the phase of the moon would be at the top there? Yeah, it's going to be a quarter moon. Because what's happening is, let me see, sorry for the cough. The sunlight's coming this way. It's going to light up this half, the left half of the moon. The right half will be in shadow. So when it's a quarter moon, you can only have a neap tide when it's a quarter moon, first quarter or third quarter, and the tides are particularly low. And then as you can see, and it's pretty cool, they're animals. Here in South Florida, we have, turtles that nest on the beaches. And I think it's during the neap tide is when the baby turtles come out and go to the sea. I might have that backwards. Maybe it's during the full moon. But anyway, there's some reasoning there about the tides and when it's best to come out. And then you have, again, the larger tides there. So this middle picture, that, by the way, is a new moon when the moon's in the middle. So you're going to have larger tides and a new moon. And the bottom picture, a full moon as well. So you're going to have some extreme tides when it's a full moon. You're going to have the spring tides. Pretty cool stuff. Okay. Back when I taught physics many, many years ago, I used to have my kids calculate how long it takes the moon to orbit the Earth. And most of them thought, well, Jeter, you just said that a month is 30 days long, so it must take 30 days. But if you do the calculation, you plug into Newton's laws, you don't get 30. You get 27. Yeah, it takes the moon only 27 days to orbit the Earth. That is called a sidereal month. So what's going on? Why are they different? Because the synodic month, of course, is what we base our calendar on. That's going from full moon to full moon. Well, I don't know if you remember from one of my last lectures, I talked about a sidereal day versus a solar day. And the reason those two things are different by just 4 minutes is because while the Earth is spinning around, it is also going around the sun. It changes. Same thing here. While the moon is orbiting the Earth in a 27-day rotation, 27-day orbit, guess what the Earth is doing? It's also orbiting something. It's orbiting the sun. And I'll try to explain this a little better on the next page with a diagram here. So the difference between a sidereal month and a synodic month, this 3-day difference, roughly 2.5 days, just over 2, I guess, 2.2 day. The difference is because the Earth is also going around the sun. The Earth is moving while the moon is moving around it. Let's take a look here. This is a little bit tricky. So you have, where do I want to start? So the Earth is coming this way. So here's sun, Earth, moon at the top. You see we have a full moon. They're all in a line. Now watch what happens here. During the month here, the moon is orbiting the Earth, and it comes around, it swings around. Now look right here at this point where it says to Regulus. We have the moon, the Earth. The moon is back in the same position that it was. Look at that. It's to the left of it again, right? But now moon, Earth, not lined up with the sun. Because the Earth, in the meantime, the moon did its thing. It went around in 27 days. But in the meantime, the Earth was moving. So now look at this. The moon has to spend a couple days, just over 2 days, sort of playing catch up to the fact that the Earth has adjusted. Now, after 2 extra days, now it's moon, Earth, sun, and aligned again. We're back to a full moon. Kind of neat. So 2-day difference there between the two things. Ancient people didn't know that, of course. They just based it on full moon to full moon, and that's how we got our months. All right. I think I better, you know what, I'm going to go ahead and do lunar eclipses in this section. We'll do solar eclipses separately. So a lunar eclipse is when the Earth's shadow is on the moon. So that means, of course, the Earth is in the middle. And for them to be lined up, it has to be a full moon. So you can only have a lunar eclipse on a full moon. And you don't have to, it doesn't necessarily, the shadow doesn't cover the entire moon. You can have a partial eclipse. Lunar eclipse can last about an hour and a half or so, a little more. maximum time, so you have plenty of time to go out and see it. The coolest part of a lunar eclipse is when you get this reddish tint, so-called blood moon. All right? Now, the reddish tint, this is kind of neat, is actually caused by the Earth. Yeah, a little bit of light that's coming through our atmosphere, skimming our atmosphere, becoming a little more reddish in color. If you think, well, why does that happen? Well, it's the same reason the sunset is red. All right? That's the way our atmosphere filters light, preferentially towards the red, orange, yellow part of the spectrum. And so a little fraction of light is skimming through our atmosphere before it scatters onto the moon, and it makes our shadow reddish, a little copper in color. Kind of neat. Another good thing about lunar eclipses is that they're kind of viewer friendly. As long as you have good weather and you're on the right side of the Earth for it, you get to see it, which is kind of cool. So anybody on the nighttime side of Earth gets to check it out. This summer, for example, just a few weeks ago, I was contacting friends in Europe and Asia because they were getting a lunar eclipse, and we didn't get it over here because it was daytime. That 100-minute period didn't line up, so they got lucky, and I was giving them a heads up about that. Let's take a look here. So here's one in London, obviously. Beautiful picture there. Love it. Time lapse. Maybe spread out over 10-15 minutes, taking different shots there during the eclipse. Here's one where they're taking many, every couple minutes or few minutes there, taking different pictures. Oh, that's gorgeous. Really neat. Different exposures there put together. Here's an interesting one. This was taken in Antarctica. Isn't that cool? The path of the moon through the sky in Antarctica. Really neat stuff. You definitely see the reddishness there. Okay. I don't quite have enough time in this one to do solar eclipses, so we're just going to stop it there and do solar eclipses in the next part. Thanks for listening.